Welcome to this explainer. Today, we're completely demystifying a foundational rule of our physical world, the fundamental symmetry of force. If you've ever wondered how things mechanically get from point A to point B, well, you're definitely in the right place. Let's just dive right in. Section 1. The mystery of movement. So, how exactly does a rocket fly into space without pushing against the ground? Seriously, think about it for a second. When you jump, you push off the floor, right? When a car drives, its tires are pushing against the asphalt. But a rocket soaring up into the vast, completely empty vacuum of space, there is absolutely no ground up there to push against. So, how is it moving?
Take that rocket soaring up into the sky. Now, I want you to contrast that with a completely different scenario, a fired gun kicking backward. You've probably seen this in movies. When a gun is fired forward, the weapon itself violently kicks backward into the person holding it. These are two entirely different situations. One involves a massive spaceship heading to the stars, and the other is a small handheld object right here on Earth. Yet, believe it or not, both of these mysteries are connected by the exact same grand principle.
Section 2. Newton's third law defined.
The ultimate answer key to these seemingly disconnected mysteries is Newton's third law of motion. It simply states, for every action, there is an equal and opposite reaction. What this means is that whenever one object pushes on another object, it doesn't just end there. That second object always, and I mean literally without fail, pushes back. And it doesn't just push back randomly, it pushes back with the exact same amount of force, right in the complete opposite direction.
Let's break down the logic of this physical transaction. We have the action, that's when the first object pushes with force. Perfectly mirrored to that, we have the reaction. The second object pushes back with equal force, but in the opposite direction. Notice the language we're using here. Action and reaction. Push and push back. It's like a cosmic mirror. You simply cannot have a push in this universe without a simultaneous, identical push in the exact opposite direction.
Moving on to Section 3, Everyday Action. Walking.
To really wrap our heads around this, let's shift our focus down to solid ground and think about the invisible mechanics at play in a totally mundane movement. Step 1. Every single time you take a step, your feet are actually pushing the ground backward. I know, you might not feel the ground moving because, well, the Earth is incredibly massive, but your foot is exerting a backward force against it. Now look at Step 2. In response to that backward push, the ground pushes you forward with an equal force. It is that exact reaction force from the ground pushing back on your feet that actually allows you to move forward down the street. Actually, think about it like this. Without the ground pushing you, you wouldn't go anywhere at all.
Section 4. Extreme action. Rockets.
Okay, let's escalate the scale here and solve our opening mystery. A rocket engine generates sheer power by pushing extremely hot gases downward at ultra-high speeds. We are talking about a tremendous, violent downward push generated by the engine. That right there is our initial action force.
And here is the big payoff. In return for that massive downward push, those hot gases push the rocket upward with a perfectly equal force. This completely explains why the rocket doesn't need a launch pad or the ground to push against once it gets into space. The rocket isn't pushing on the ground, it's pushing on the gases. Because it forcefully ejects those gases downward, the gases exert a mathematically perfectly equal reaction force upward on the rocket. That reaction is the exact mechanism that allows the rocket to rise into the sky and travel through the dead vacuum of space. Pretty mind-blowing, right?
Next up is Section 5, Fluid Action. Boats.
We've covered solid ground and the vacuum of space, so now let's explore a liquid environment. Imagine you're standing in a small boat right near a dock. When your action is to jump forward onto the shore, the boat simultaneously moves backward into the water. Why does that happen? Well, because to propel your body forward toward the shore, your legs had to push backward against the floor of the boat. Your jump pushes the boat backward, and in that exact same split second, the boat helps push you forward. It's Newton's third law in action right there in the water. Section 6. The universal rule, force symmetry. Let's bring all these diverse examples together. This single symmetry of force dictates an incredible variety of movements across our entire physical world, whether you're just casually walking down a street or launching a massive rocket reaching space. It governs you jumping off a small boat or even just swimming through the water, where your arms push the water backward and the water reacts by pushing your body forward. This one invisible rule is constantly working behind the scenes in literally every environment imaginable. If you take only one thing away from this explainer today, let it be this.
Every action has an equal and opposite reaction. It is a beautifully simple, totally unbreakable symmetry of force that makes literally all movement possible. I want to leave you with a final thought to mull over. Where else do you see action and reaction forces secretly at work in your daily life? Now that you know the hidden physics of walking, rockets, and boats, I really encourage you to look at the world differently today. Watch how things move, watch how they bump into each other, and see if you can spot the equal and opposite reaction keeping everything in perfect balance. Thanks so much for joining me on this explainer, and keep learning.